Hello and welcome. Once again, this is electricalaccess.com, and today we're going to discuss the fundamentals of electricity. We will cover today the electron theory and its fundamental units and quantities. But before we proceed, please subscribe below and hit the notification bell for more videos. In studying basic electricity, we will discuss first the electron theory, which is now accepted and used to explain the behavior of electricity. And it states that the electric current consists of an electron flow and can be defined as a moving charge. Now, to understand it deeply, we will also study the composition and the characteristic of an atom. Atoms, as we all know, that this is the fundamental building blocks of matter. In fact, many scientists believe that everything in the universe are made up of atoms. An atom has three main components, namely the proton, which is positively charged, the electron, which is negatively charged, and neutron, which is neutrally charged. The electrons are negatively charged particles of an atom. Together, all the electrons of an atom create a negative charge that balances the positive charge of the protons inside the atomic nucleus. Electrons are extremely small compared to all other parts of the atom. As we can see here in our diagram, we have the nucleus in the central part of an atom. Now, surrounding the nucleus are the orbiting electrons. I just want to emphasize here right now the presence of the valence electron. The valence electron is also called as the free electrons and is always located on the outermost shell of an atom. Outermost means the last shell. As of this point, we're going to discuss about the atomic structure of conductors, insulators, and semiconductors. As described from the figure below, we can see that the conductor has 1 to 3 valence electron. On the other hand, the insulator has full valence shell, while semiconductor has 4 valence electron. It is very important to know the conductivity of material based on the number of its valence electron. Let's start with the conductor. The valence shell actually needs 8 electrons to be full, but conductors have only 1 to 3, and the energy required to allow this electron to escape in the valence shell is less. And for that reason, we consider metals like aluminum, copper, and gold to be a good conductor of electricity because these materials has a valence shell of only 1 to 3. Now, let's discuss about the insulator. Insulator are materials that do not conduct electricity. The primary examples are glass, porcelain, plastic, and rubber. And insulators do not conduct because they have a full or nearly full valence shell, and thus the electrons are tightly bound together. If a high voltage is applied to an insulator in such a way that the force is so great, now the electrons will turn apart from their parent atoms, and this will cause conduction to occur. This happens in the arc flash in the electricity. Now, semiconductor. Semiconductor has 4 valence electrons. These materials are initially insulator but can be a conductor if it gains enough thermal energy that may break the covalent bonds and become free electron of negative charge. As of this point, we're going to summarize the topics that we have discussed from the electron theory, and we just discussed the composition of an atom as well as the electron, and also the valence electron and its relation to the electrical conductivity of materials. Now let's move forwards to the electrical units and quantities. It is because very important also for us to measure the quantity of electricity. Now the first in line is the electric current. Electric current is defined as the rate of flow of electric charge past a point. What does it mean? Now imagine that this is a conductor, what we can see here in the diagram. Now along the way, we're going to establish here in an imaginary line represented by a red vertical line. Now in this case, the amount of electric charge that will pass through this line in 1 second is called the electric current because it signifies the rate of flow. The symbol for electric current in electrical engineering is I, and the unit is ampere or amperes if it is more than one. It is represented by a capital A. Now, 1 ampere is also represented by a composite unit of 1 coulomb per second. Now, if electric current is the flow, what causes it flow? Okay, so let's move forward. Now, the second one is the electromotive force. Electromotive force is a source of energy that can cause a current to flow in an electric circuit or the device. The symbol for electromotive force is E and the units is volts. Now, there are different sources of EMF which causes the electrons to flow. Number one is the electromagnetism. Number two is the chemical reaction. We also have the Seebeck effect. We have the photoelectric effect. We also have the piezoelectric effect, and we have the friction. Okay, now let us discuss this one by one. First, the electromagnetism. Electromagnetism is a branch of physics involving the study of the electromagnetic force, which is a type of interaction that occurs between electrically charged particles. Now, how this phenomena can cause the electron to flow? First, we need to have the three components. Number one is the magnet. Number two, we need to have a conductor. And number three, we need to have a relative motion. Now, as we can see in the diagram here, we have two magnets and it is represented by north and south pole. In between, there is a magnetic field. Now, according to the theory, if the conductor is moving in the in the magnetic field, then the electrons will flow. As you can see here in the green color, there is a moving needle pointers. Then it denotes that the electricity is actually moving. Okay, let's move forward. By the way, the primary example of the electromagnetism is the electric generator that we can find in the power plant. The second example of electromotive force, as discussed above, is the chemical reaction. This happens actually in the battery. Now, the battery involves the flow of electrons from one material or electrode to another electrode, and it is being connected through an external circuit. Now, the one who discovered this is an Italian physicist named Alessandro Volta. In his experiment, he found out that if the two dissimilar materials is being soaked in a chemical called electrolytes, then the electrons will flow from the first material to the other material. And this flow of electrons provides an electric current that can be used to do work. In our example here, the load is an electric bulb, and so when the electrons is flowing, then the energy will be converted into light. Now let us discuss the Seebeck effect or thermoelectric effect. The Seebeck effect is a phenomenon in which it states that the current will flow when a temperature difference exists between the junctions of two dissimilar electrical conductors, such as iron and constantan. In this example, we have two different lines colored red and colored blue, which represents two different materials. Now, if these two materials are connected to each end, one is junction is a hot junction, while the other end is a cold junction. And then, according to the theory, the electrical current will flow in this situation. The practical example of Seebeck effect is a thermocouple, which is very popular in instrumentation because thermocouple is one of the types of temperature sensor. Next is the photoelectric effect. The photoelectric effect is a phenomenon in which electrically charged particles are released from or within a material when it absorbs electromagnetic radiation. The effect is often defined as the ejection of electrons from a metal plate when light falls on it. And the practical example of this effect is a photocell. Now imagine that we have an automatic switch in our street lighting system. When the sun appears in the morning, we can see that the street lights will automatically switch off. while on the other hand, in the presence of darkness, the light will automatically switch on. So this happened actually because of this photoelectric effect that puts it into a practical application. Now, we have also the piezoelectric effect. The piezoelectric effect is the ability of certain material to generate an electric charge in response to applied mechanical stress. The practical example of the piezoelectric effect is the load cell inside the digital weighing scale. As of this point, we already completed the enumeration of the sources of electromotive force, which causes the electrons to flow. Now, as of this time, we're going to discuss the electrical resistance, which is last among the basic electrical quantities. Electrical resistance is defined as the ability of the material to oppose the flow of electric current. Now, if the electromotive force is the one that causes the electrons to flow, on the other hand, this resistance will try to oppose it. That's why the term resistance, it always resists. Now the symbol for resistance is R and the unit is ohms, and it is expressed by a capital, the Greek letter omega. Now there are characteristics of electrical resistance which affects its value. Number one is the type of the material. Number two is the dimension, and the number three is also the temperature. The resistance, the type of material affects resistance because different material has different resistivity. It is inherent to the material. Like for example, the copper has different resistivity compared to aluminum. Now what if the material is are the same? For example, the same copper, the resistance also will change according to the dimension. So for example, there are two coppers. one is uh, one is shorter while the other is longer. So from the formula, which will be discussed in the other video, the longer copper conductor, has higher resistance compared to the shorter copper conductor. And last, the temperature. Even though it has the same material, for example, the same copper material, and it has the same dimension, the same length, the same cross-sectional area, but it is subjected into different temperature. One is placed in a chamber with temperature of 20 degrees Celsius, while the other one is placed in a chamber of 40 degrees Celsius. According to the principle, the conductor which is placed in the higher temperature, which is 40 degrees Celsius, has higher value of resistance. And these lessons will be discussed in the other videos. As of this time, we already completed the the lesson, the electron theory, as well as the basic electrical units and quantities. And I hope that you learned from this video, and thank you for watching. So please subscribe for more videos to come. Thank you very much.